An engineer chooses open collector output TTL technology to provide sufficient current to drive a device. Now, the open collector output TTL technology is simply means that the output is just simply connected off the collector of the transistor. A circuit shown is implemented with a 7405 package and corresponds to the following function, where 0 is 0 volt and of course 1 would be some VCC anywhere between 5 to 7 volts, right? Interesting thing is over here that the output of the 3 inverters is actually shorted and then fed into this inverter, which is labeled as TN. This is ideally not the best way to wire it up, and most likely, if we're gonna have to try different combinations here. Say, if all the inputs are 0, it's very similar to that you have 3 batteries connected in parallel of the same magnitude, and that's not the good way to do it, because you're basically shorting it, and then there's gonna be, it's just not good. So if I have same set of inputs, 000, you're going to have the same output 1, 1, 1, which will be some volt, and it will be, the 3 voltages will definitely be equal. So you have 3 batteries now, think of it as a batteries, each at equal magnitude. That would work. So you get 1 here, and then at the output you get F equals to 0, correct? So in other words, 3, 0 give you 0, right? Similarly, if you have 1 here, then the output of the inverter will be 0. So same magnitude, and so you get 0 here, it gets inverted, and you get 1. But if any of the input of A, B, and C, say is 1, and say, the other 2 are, say, 0, right? So we basically get 0 here, and you get 1 here, and you get 1 here. Now we got the voltages of unequal magnitude, because you may get 0 volt here, but you get 5 volt and 5 volt here, right? And again, this is like a shorting together on the voltage sources of unequal magnitude. It's not desirable, and it's going to just simply have 0 here, 0 here, and it gets inverted, and therefore you get 1. So the logic here is pretty simple. For any input ABC is high, the input to the inverter is going to be just simply 0, and resulting in F equals to 1, because 0, when it gets inverted, you get 1. That is a property of an OR gate, actually. So what does OR gate says? Any input high, output is going to be high. So any input high here, output is going to be high, which was the case in the last 2 combinations.